So thanks again, Steve. So for very briefly, I just want to follow up with a few more examples of recent RTLS deployments in the manufacturing space. So firstly, EJOT, a group of companies that specialize in fastening elements, deployed Bluetooth RTLS technology to track order movements on the shop floor. And what this did was resulted in search times being decreased by 75%, reduction in overall errors, and improvements in the overall production throughput. So very much aligned with some of the pain points and use cases I mentioned earlier. Similarly, 3B Hungary, a producer of material handling and conveying equipment, used ultra wideband to help identify the correct steel assembly parts in production. And again, with these kind of parts, they can be easily misidentified because they're very similar sizes, very similar shapes. And despite the kind of harsh industrial metallic environments, ultra wideband was able to deliver 60 centimeter accuracy and reduce search times by 90%. So very considerable improvement there. Another aircraft maintenance department of a global aviation group also leveraged ultra wideband to track aircraft components throughout the whole warehouse process. And again, this helped to save hours through reductions in search times, reduced loss of assets, and made sure that the correct parts were being leveraged at all times, which had a reduction in the cost of rework and errors as well. So again, these are just a very few examples, but it highlights how technologies such as ultra wideband and BLE are solving some of those key industry pain points we mentioned earlier, thanks to the accuracy, reliability, robustness, and ability to operate in these kind of harsh industrial and manufacturing environments. So you can really begin to see how RTLS and why RTLS is such a vital component of this digital transformation and digitalization across these environments as they increasingly adapt to the number of pressures that they're facing, which I touched upon earlier. So finally, I just want to very briefly discuss the roadmap for 5G positioning, which is becoming, a very or extremely hot topic within the RTLS and location industry, both indoors and outdoors. In its simplest form, the ability of 5G to combine connectivity with high precision positioning has the potential to significantly enhance the value proposition of 5G and private network rollouts, and help to enable these new location-based services across a wider variety of enterprises. So the idea is that the same 5G network that's leveraged to connect these thousands of assets and user equipment across different market verticals can also be utilized to determine the very precise position of the very same assets. So as you can see from this slide and the roadmap, really, what 5G positioning aims to do with the arrival of 5G Advanced is to bring new enhancements to cellular positioning over time. And the idea is it's more accurate, going eventually towards centimeter level accuracy. It becomes more reliable. It's very seamless and scalable in terms of operation, both indoor and outdoors. And that enables, enterprises to take advantage both of the 5G network, but also positioning capabilities it will bring. And again, by leveraging the kind of standards-based approach to 5G, the idea is that you can benefit from the global rollout and larger scale adoption of 5G as the densification of 5G infrastructure grows over time as well. So the idea is, of course, in contrast to other short-range technologies, such as Bluetooth and ultra wideband and GNSS, which is restricted to outdoors, 5G can ideally, cover or have the ability to cover both the indoor and outdoor environments, having that kind of seamless use cases both on and off campus. And again, this brings advantages in terms of the deployment rollout, the complexity of the rollout, reduces the infrastructure costs because you can recycle the network infrastructure, as well as other security and management capabilities as well. However, I just want to also highlight some of the limitations to 5G positioning, especially as we stand today. Naturally, of course, 5G positioning faces a very strong competitive landscape from other technologies, some of which we've mentioned today, like ultra wideband and BLE, which are also continuing to evolve and develop as well. And 5G positioning as it stands can't meet the same metrics, whether that's power consumption, whether it's accuracy. And it also may be very cost prohibitive to some of the kind of smaller to medium sized enterprises, which don't necessarily have a private network deployment. Therefore, it's not as cost effective for them to be able to roll out our solution. And of course, one thing with 5G positioning is power consumption. Until very recently, 5G positioning has kind of lacked the framework to deliver on low power consumption and low terminal battery life, which obviously provides some limitations when you're talking about tracking thousands or hundreds of thousands of assets across different facilities. And again, we really see, you know, it's not necessarily guaranteed that the rollout of a private network will also guarantee or be able to guarantee kind of centimeter level performance across all use cases. There may still be the need for additional anchor points and reception points, time synchronization, or millimeter wave type deployments to get the required accuracy that technologies such as ultra wideband can provide today. And again, there may be some knock-on impact if location isn't necessarily the focus of the core network. It may be the fact that they may be prioritizing data over the location accuracy. So a lot of these factors need to be considered, when talking about 5G positioning and kind of realistic timelines for it. So from our perspective at ABI, we don't believe that the 5G positioning revolution is going to happen overnight. The large scale deployments of this technology, we expect to be 3 to 5 years from now at the very earliest. And that will be starting with a kind of less stringent, meter level applications, and maybe then progressing further down the line to more high precision, sub-meter and low power applications for more safety critical and autonomous applications. But again, this will depend very much on, the rollout of the third generation partnership project timelines, the rollout of private networks across, of course, enterprises to support this technology, and various industry collaborations as well need to happen as well. So in essence, there's a lot of interest around 5G positioning, but the technology won't really mature before 5G Advanced comes. We don't see it as replacing existing technologies. Instead, we see potential for new hybridization type deployments where you can have potentially ultra wideband and BLE alongside 5G for greater coverage across a whole facility. 5G, of course, can also be used as a kind of backhaul network to accelerate the rollout of traditional RTLS deployments as well. But I think this is going to be something where today we don't think there's a need to hold back and wait for 5G positioning to arrive. RTLS today, as we've seen from the previous presentation, that it's already addressing many different key pain points and challenges and obstacles that are finally being removed. So we expect these other RTLS technologies to grow in the coming years, and maybe 5G will become another element in the toolbox that can help accelerate broader RTLS deployments. So that's all from my side today. I hope you found this overview useful, and it's been a pleasure sharing some of our insights on the market. Again, we don't believe there's a one-size-fits-all technology, but decisions will need to be made depending on specific environment, the use cases, and overall the needs and requirements of each individual enterprise. Thank you.
Great. Andrew, thank you very much. Really insightful presentation, and great to see some of those use cases and also some of the future technologies that might help us as we think about this in years to come. We actually had a quick question here from Anna on our portal. She asks, can you outline the differences between RFID and RTLS as you talked about them earlier?
Yeah, so absolutely. So we traditionally segment the market in when we're talking about real-time location systems, we're normally talking about assets that are pretty much tracked in real time, and you have a strong sense of their position and where an item is at all times, and that can be across a factory floor. It could be into logistics applications. The reason why those technologies tend to go towards Bluetooth and ultra wideband and active RFID is because they can provide much more frequent updates. They can provide coverage across the whole entire workspace, whereas more passive RFID has traditionally been limited to kind of choke points at certain parts of the facility, so you can determine when an item's gone in and out of a certain area, but not necessarily where that item is within that area. So there are a number of advantages to leveraging the real-time location technology, technologies such as ultra wideband and BLE that can provide that kind of meter level accuracy within a thing, so within an environment. So whether that's tracking a tool on a factory floor, whatever it may be, personnel, for example, you can't really leverage traditional passive RFID for that solution. So those other solutions are more optimal.
Fantastic. Thank you, Andrew. And I think, as you mentioned in your presentation, it's those combination of technologies where we can find some real value depending on what you're trying to achieve.
Absolutely, and I think those will continue to emerge and grow over time. Right? We talked about the arrival of 5G positioning, the ability to have seamless indoor and outdoor capabilities, being able to reduce the overall cost of the installation as well, right? So combining what could be ultra wideband for the more stringent, centimeter level applications, alongside Bluetooth for more kind of meter level accuracy, and maybe then LPWA or 5G for the kind of indoor outdoor, and GNSS as well for the kind of outdoor location applications as well. So we'll see that converge over time, I think, as well.
Fantastic. Andrew, thanks again for joining us. Really great to have you as part of our event, and we look forward to talking to you in the future. Thanks.
Pleasure. Thank you.